great. So hello again. I'm Mahdi Afkhami, a PhD student at Purdue. I work with Dr. Emad Elwakil, and today I'll be presenting our project, which is a resilient-based method for prioritizing individual housing fund in a post-disaster scenario. Natural disasters happen in the United States every year, and it costs millions of dollars. Just in 2018, the FEMA, or Federal Emergency Management Agency, spent more than $105 billion in individual assistance. And as in the United States, floods and storms and hurricanes are the most dominant natural disasters that happen and cause the most displacement. And there is a limited range of insurance cover in some of the regions, which is actually alarming and causes some concerns. Currently, what happens in the allocating individual assistance to applicants is basically on expert opinion and tacit knowledge, which is obviously makes it prone to errors and insufficiency. And as we go forward, this issue becomes more complex because we have population increase and density growth in our cities, especially the coastal areas, which are most prone to flooding and hurricane and storms. So the gap that we are seeing right now is that there's not many studies focusing on how this process of allocating individual assistance grant to application is being done. There have been some studies of showing how the federal disaster aid affect households when they're purchasing disaster insurance, but that again is limited and it doesn't exactly cover the issue that we're talking about. So what we're doing in this research is actually the need to optimize and defining the spending of this budget, and how there's a need to outline a new method for inspecting and applying these funds for applicants. So what we're gonna do in this research is that we're gonna use 3 different regression techniques to show how it can use the FEMA decision makers in these times. We also gonna look at the effect of some socio-demographic variables in each region and how it would affect the amount of individual assistance. So the type of regression models that we will be discussing in this research are 3 multivariate supervised machine learning models, which would be a multiple linear regression, the linear support vector regression, or SVR, and poly-SVR. The dataset used for this research was from FEMA preliminary damage assessment reports, and the data that we used actually shows the amount of individual assistance spent from 2015 to 2020. So what is individual assistance, or IA? So when a disaster happens, there is a agency, there's a group, disaster relief fund to pay damage. IA is a part of this disaster relief, which helps individual to live in temporary places. So this is not for the permanent houses, for temporary. And it would also have essential home repairs, temporary housing costs, and other necessary expenses. So the machine learning that we use is actually a great tool for multivariate decision making when there is an uncertainty. The traditional decision making, as I explained earlier, are based on tacit knowledge and people's experience, which makes it really subjective, and it's prone to error, and it can be inefficient. So what machine learning does is that it uses the past data to make a decision and find the pattern. Therefore, it makes it more reliable and accurate, and something that can be worked with for a many long time. So this, in this part, we studied the socio-demographic and how they would affect the amount of the IA or individual assistance. So in these graphs, so the size of the data points are actually the number of the uninhabitable homes created by floods or natural disasters. The horizontal bar shows the amount of individual assistance in the dollars, and the vertical axis shows low-income households affected by the percentage. So here, for example, you can see, and also we are showing the mean value of each parameter in the graph. So we have these two lines that shows the mean for the values. For example, here you can see that for Texas, as the low income, the percentage of the low income people increases, we also have an increase of the amount of individual assistance that being allocated with them. So you can see actually the relationship between these two factors. We did the same thing for the insured houses. So the percentage of the houses that are being insured actually. Again, you can see a pattern that the lowest number of insured places suffered the most and actually used the most amount of the individual assistance budget. So in the next stage, what we did is that we used these data. So we had our independent variable list, which was the number of the low-income houses, percentage of the insured people, those who were affected, and their houses were either destroyed, had minor damage, or major damage. And the outcome for this modeling was the amount of individual assistance. So this is what we did. We created 3 different models in Python using the scikit library, and for validating our model, we used the train test split, where we split the model into 2 groups. So 80% was for training the model and 20% was for testing. The graphs that you can see here, the horizontal axes are the Y test or the outcome of our test model, and the vertical axis is our Y predict or the outcome of the predicted model. So here you can see how these data work with each other, collaborate with each other. And so here, for example, so the first one is linear regression, second one is the linear SVR, and the third one is the poly SVR. And you can see how these models are actually accurate and help us in understanding the individual assistant model. So as a result, as seen here in the research, actually machine learning can help us to create more accurate outcomes, as well as it can help us to increase the efficiency. And it's obvious that the amount of individual assistance is affected by factors like low income and number of insured houses. Because of this, poverty actually plays an important role in the number of people being affected by natural disasters. So this would be kind of another research opportunity for future research that can help help policy makers and urban planners to actually gain insights on how they can plan their urban or their community in order to be more resilient. So thank you so much. And if you have any question, I'll be happy to answer.